Hi guys, recently I did a video on upgrading that dual Chinese power supply, uh, and one of the things that I needed was a board with 3 relays on it, so that I could mount a switch on the front panel to actually um, stop the power output and turn it on and off, sort of thing. So that got me thinking. It would be kind of neat to have a general purpose relay board that could be used like with an Arduino or some logic circuits that can actually turn a relay on and off, even to switch off, 230 or 120 volts in North America and so on for to power something. So this is what I've come up with. I went into KiCad and I designed a relay board with 3 relays on it. The one that I needed for that power supply actually needed 3, so I thought, well, I might as well create a board that can have up to 3. And I didn't want to limit it to the one kind of relay. I put 2 relays here in parallel, but in actual fact on the PCB you will see that they would be on top of each other. You only mount one or the other, but in any case, this is how I did that. So this big relay here is actually it's got a footprint it's a large relay. We'll look at it in a minute. It can handle up to 30 amps, I believe, maybe even more. What is 40 amps actually? Can handle up to 40 amps, and this one here can handle up to like 10, even 20 amps at a lower voltage, but it's much smaller. And both of them are 5-volt relays, and which means they can be driven off a 5-volt power supply for like the logic circuits. And it has a optocoupler here, so that in case you're using this thing, with a high voltage, AC voltage, that it is actually separated from the circuit with an optocoupler, so that no high voltage is isolated, so no high voltage can actually get into the inputs here. And what I've decided to use is this LTV354T opto isolator, Lightion or whatever companies makes those. I bought 100 of them for $8.80 on AliExpress at free shipping, so they are nice and cheap. But what's unique about it is that unlike most opto isolators that just have one light emitting diode in it, it has 2 that are back to back. So you can actually wire it up to actually respond to a low going signal or a high going signal. So if you're driving it off something like an Arduino or some other logic circuit, you can decide whether you want to be active low or active high. And this is actually done via a little jumper over here. It defaults to inputting a high signal to turn it on and low to turn it off, but it's a little solder jumper. If you cut it there and put a blob of solder on there, then it could be used in active low mode. I put a resistor on there and a little connector to mount to go to an LED if that is required, so you can see when it's on. And the way I've laid out this board is that you can actually separate them into separate little boards with one relay on it, or you can have 2 relays or 3 relays, and that's why each one has separate mounting holes, so that they are actually over there. And of course, the opto isolator, these big relays like the 40 amp one, I think it draws 150 milliamps or something each, so that is more than the opto isolator wants to provide, so therefore there is a transistor over here that actually turns it on, has more current capabilities, and also there is a diode, of course, to dampen down the reverse voltage that's generated in a coil when you turn it off. It's an inductor after all, so it would generate a reverse voltage, and that can be detrimental to the circuit. So this dampens that out, and so that's normal practice. So if we look at the PCB, this is kind of how it is going ended up being laid out. I originally did traces for the pins for the relays, but then the high current one, you might be drawing 20 amps or something, so I also put I filled the zones up here in the background, so it has actually more current capability that way. And these inputs, inputs are separate, but I did connect the power, the +5 and the ground together via these traces over here, the blue ones. But of course, if you cut them, these are slots, makes it easier to cut them apart, separate them out. Then of course you would have to apply the voltage to the pads on these connectors over here. So whatever you think is appropriate. The little jumper is over here. I guess I could make it a bit larger so you can see. That's the solder jumper. See, it's jumped over here. This is open, and you can cut it there and solder it over there. This is the transistor, diode, and so on. And as you can see, there is actually two relays superimposed on top of each other here. The big one is the K1, and the small one is like the relay 1B. See the outline of it here. This causes the some of the software to complain because it thinks that there is some overlapping of components here, but we can ignore those errors because all we're concerned with is that sometimes we want to use the small relay and sometimes the big one, and you only put one or the other there. In any case, let's have a look at what we have, the components. So this is the big relay, and this is not the they will be like the ones that are mounted on this board, but this one actually, even though it is just slightly larger, the pins are exactly the same spacing. So what I normally do is I print out the PCB here, and I double check that all the pads are in the right place. So this is going to be the heavy duty outputs screw terminals, and as you can see, they line up with those pins there, and they would be mounted like that, so that fits. And then of course over here is going to have one of those, see that, 3 at a time, that fits over here. And this is for the LED, and it is you could just solder wires on there, or you can have 2 little pins or whatever, or another one of those with 2 connections, whatever suits. And you might notice too that there are slots cut around these pins over here, and that's what you normally do when you have potentially the voltage on there could be 230 volts or 240 volts AC, or 120 in North America. So to separate the high voltage from the low voltage stuff, to make absolutely sure that there can be no problems, that's normally what you do. You make little slots, and you'll find that they've done that over here as well. You see, they've got little cutouts around the pins there. So that's normally what you do. And of course, these are the cutouts to make it easier to cut the boards apart. There probably is a way to do that in a different way with some that you can snap them apart, but I didn't want to do that because I want some strength to be there in case you use all three and you're going to mount the board on something. And so the pins over here, let's have a look, they line up. See, that would be how the big relay fits. And I've checked, it uses those little fat pins over here. And this one over here lines up with the other pins over there, like that. And it would mount like so. And they would be using these smaller pins over there. No, those, sorry. And that's all there is to it, actually. Now, what I got an email from a company called NextPCB. Most of these YouTubers seem to be sponsored by PCB Way or JL PCB or something like that, but my channel is not as big, and they've never spoken to me about it, and besides, I'm not really making any money whatsoever from this YouTube channel. I don't get enough, I don't even get monetization from Google either, so everything that I have to buy myself. But they did say to me that that they could give me some free samples of PCBs to try out. So that's what we are going to be doing. I have not actually used KiCad to generate Gerber files and send them to a PCB maker. So it's going to be an interesting little project. But what is unique about them, they have let me go back to the screen here. They have an online tool. They also have one that you can download for Windows. I've actually downloaded it, but to be honest, I like the online one better. It does seems to do the same job. And what you do is you go to KiCad and well, let's go to the board view here. You go to plot and you select Gerber, and you check all the bits that you wanted to generate. I've got no user comments, no user edge cuts, margins, so that'll be pretty much it. And I think you can turn that off, and you would then there's some options there which disable aperture macros. Some of the things I don't even know what they're for. And then you say plot, and then you will generate the drill files. But I have already done that. And when you look at see, they're all here. These are all the GBR Gerber files. And what you do is you take all the Gerber files, not the PDFs. They are what I use to print out that printout that you saw earlier. You select all the Gerber files and the drill files, and you put those in a zip file. So that is it there, relay board zip. And when you go to this website here, let me go to now this is on a different screen, so you can't actually see it, but I'm going to highlight relay board zip like so, and I drag and drop it up here, and it actually analyzes the files. The PC version, you have to actually highlight all the files and drop them on there, not as a zip file but all by themselves, but it seems to have a few little bugs in there. It's fairly new software, I guess. Any case, but as I said, I actually like this one, the online one, better anyway. So it's ready in the Gerber file, so this is what it is coming up with, and that looks pretty good, I think. And over here you can actually turn things on and off. That's the silk screen. Top solder, you can turn the whole top layer off. Let's bring in the bottom layer, and drill files. It does a it analyzes your files and tells you if there's any problems, and it does complain about a few things, but and some I'm not quite sure what they are. I've sent the files to NextPCB. They can tell me if that's a problem, but according to what I'm reading here, the drill to copper NPTH to copper recommended increases spacing. That's of no importance to me, just only a warning anyway. Here it's got angles on the traces. That is also a warning that is of no importance to me, because the relay board, it doesn't have any high frequency signals at all. You turn the relays on and off, it's a low frequency thing. Board adds to copper clearance. It says it's risk. It's not actually an error. There's nothing there that I can see that bothers me either. And because I've got those two relays on top of each other, and they got some silk screens there that interfere with each other, they will say that might get into the pads and everything. I don't think that these errors are actually anything to be concerned about, and it shows you what the PCB is going to look like. I selected green, and it's got holes, so I think that's all good. So that's kind of a neat feature that they have, that you can actually analyze your PCB, the way it's going to come out, and make sure that there is no errors there that would cause them not to work. So that's what we have. So I have actually ordered the PCBs, and now we're going to be waiting until they come, and then we will test the whole thing out and look what they look like, the quality of them, and so on. Of course, another service that they offer is to actually populate the board with the components on it, but in my case that is not something that I want for these, because I want the boards by themselves, and depending on the application I might want to use a big relay or a little relay, and sometimes I might want to mount screw terminals, sometimes I don't, and so on and so on. Of course I could get them to put the opto-isolators and the resistors and the transistor and the diode on there and so on, but these are easy to put on. Besides, I enjoy soldering those things, so that's not a feature that I would want to use for this particular board anyway. Anyway, next I'll await when the boards come, and then we can resume the video. Okay, so I received the PCBs. They actually sent me 6 of them, and they are pretty nice. This is the first time in actual fact that I have used KiCad, and I've left all the defaults in place and just sent the Gerber file to them, and that seemed to work. The PCBs came into this box, nicely packaged, so I'm quite impressed with their service. It was good and fairly quick, so I'm sure to use them again. However, there's only one little problem that I see, and that's not their fault, it's kind of my fault being unobservant. So if you look at the what is supposed to be printed on there, I was expecting this, and you'll see that, like here for instance, it says 2 LED, in pin, and 470 R, 220R, the little diode symbol, and so on. Nothing serious, and of course normally open, normally closed over there. And if you look at the actual little boards, you will notice that that text is missing. You know, it's kind of like, this is where the diode is, and it just says D3. So what I've determined is that for some reason, and I've never really taken notice, you know, I've always made my PCBs myself, and it's got no screen printing on there, so I've never really taken any notice of that. But some of this text here, like this 2 LED, the 470R, everything sits on this layer here called front fab. See, if I turn that one off, now it's all gone, and that's indeed, this is what we have on the screen printing on the board. And I should have known that, because there is a NextPCB has a free Gerber viewer, and as you can see, when you view this over here and I take away the traces and things like that, then all we got left over is exactly what is on the board. So it's just, I didn't notice that. And so what I need to do next time is I have to make sure that I put text like on the only on the front silk screen, and I can actually select T for text, and I can say like that one of the things that was missing. See, and it says front silk screen, and I can rotate it, and then I can actually pull it over here, and now of course that would be on the silk screen. So next time when I do this, if I'm gonna get PCBs from NextPCB, then I've got to make sure that my files are correct, and obviously that's the only little thing, but the rest, there's nothing wrong with them, everything is just great. So as you might remember, now it's taken a couple of weeks for me to send this to them and to receive the boards, and the previous part of the video I did a couple of weeks ago, so I myself have to remember kind of what I said. But what I was actually doing here is, see, I've got these cutouts over here, and that allows me to actually, I can use this as a board with up to 3 relays on it, or I can cut one off and have 2 relays, or I can cut them all separate, and that's in fact what I have already done. We're going to make 2 little prototypes here for the testing, and these can all be run separately. And let me see, where's the other one? Yeah, I got 3 of them, of course. We're only going to use 2. On the circuit I actually have 2 relays. There is one here, K2, and relay 2 on this part of the schematic here. And we never intend to put 2 relays on this board, but I did that so that I actually cheated. I put one on top of each other so that we can actually either have a smaller relay or a bigger relay. And that's what we're going to do. You can see the outline over here of the bigger relay, and that's going to house one of these big boys up to 30 amps, and the other one we are going to put this little guy, and I've already tested, they fit perfectly, so that's why we did that. So that's a success. We are going to put on one of these screw terminal things here for the big one. The little one I'm actually going to just solder wires on there, I think. It's all flexible. These guys here are going to be there. This of course is for an external LED, and that's the power, 5 volts to run the relay. I might even do a third one and run it. I've got a 12 volt relay, so we can test it at a higher voltage, but for now that will do. We've got our just move this off for a sec. We've got our little opto isolator, and this is this little weenie transistor over here. We're going to do some soldering under the microscope, and this here is the jumper. We shouldn't have to do anything. It should be connected so that it is positive, and as you can see the negative symbol there. If I cut this open and solder a blob of solder on there, then the it'll be negative logic, so it will respond to like a 0 volts instead of 5 volts input, or 3.3 volts it should work with. That's because this opto isolator is a special one. It's got two back-to-back diodes in there, and I've got to get myself a couple of resistors, so they're going to come out of this little kit over here. So I think we might do the big boy first. So I need that, and I'll need those components. Oh, I've got a few little diodes over here as well that we're going to be using. So we're going to do the surface mount components first, because they are the trickiest, and we don't want to have big pieces of components on there that's going to get in our way. Okay, so we have this thing under the microscope. Now let's have a look. We want to do a teeny weeny resistor here. And first thing I'm going to do is, could use hot tweezers, but I prefer to do one side first. I've got my finest soldering iron here. Put some solder on one side first, and then I've got my super tweezers here. I think they're made in Switzerland or something. Okay, that's one side done, and then I'm using proper flux here. It is called NC559V3TF. This is the real stuff. A lot of other people on websites are actually selling, they say, oh, this is the real flux, but it's not the latest and the best. This stuff is, if you're looking for it, it's MTech, and they call it version 3 Techie Flux. Great stuff that is. Okay. Now let's have a look. We are looking for a 470 ohm resistor. They're so small I can't see them except when I put them under the microscope. Yep, this is it. kind of a strange marking on these things. It's 470 times 0. You would think it's 4,700, but it's not. Okay, so this one goes over here. Again, I'm going to add a little bit of flux here. It's sure nice to have a PCB with solder mask on it. Normally when I'm soldering these things on my own PCBs, I don't have solder mask, and it actually makes it a little harder. But the solder will only stick, you know, where the pad is exposed there, so that is makes it a lot simpler. I think I'll use these NextPCB people again. I do my prototypes, you know, maybe with my own PCBs, because that's quicker. I can do it immediately. But if I'm actually making things, I can order some PCBs and do it on a better looking one. Alright. See if I can get that a little clearer maybe. Yeah, that's a little better. Now, the last one. This one goes over there. This should be a 220. They're so small they stick to the tweezers. Come on, off you go. Yep, that's 220. Reason why we are doing one side first is that the other side can lay flat on the pad. Otherwise, if I put solder on both pads, it'll be raised in the air, and then I'd have to push it down, and then sometimes when you do that, those little things, they snap away. I think I need to pull this one over a bit further. That's better. Need to have a little bit of pad there to put some solder on. Using my andthe soldering station. It's sure nice to have some decent equipment to do that. Got it set for 333 Celsius. Now we have a little transistor here. And it's amazing, these tiny little transistors can handle a half an amp. You wouldn't think so, would you? 500 milliamps. Okay, so similar deal. I'm going to do the little collector, which is the middle pin. So what that actually is for is that we're going to be soldering a opto-isolator on there for two reasons. So it's isolated because these guys here can have, you know, 240 volts on them, AC, or 120 in the United States, and you want to make sure that if anything ever goes wrong, that the high voltage doesn't get into your circuit, so that isolates it. But also, if you're running this thing off like an Arduino or something like that, it has limited output current capabilities, then the opto-isolator only takes a little bit of current, and then it will then drive the transistor, and the transistor can handle up to 500 milliamps, and this big relay that I have takes like 150 milliamps to stay on, so would be more than even if you didn't have isolation in mind, it would be more than what the like a Arduino or something like that could handle. Oops, you see it? I mean, you got, I think I'm going to use a different kind of tweezers here, because this one is a little bit bigger, and I got these ceramic tweezers that are, they clamp on without me having to squeeze it, so that makes it a lot easier. I don't have to worry about what just happened, that I snap away while I'm concentrating on doing something else. Actually, maybe a little bit more solder on that pad. What do you think? Now I've got to look at the screen. Okay, very good. This is, I'm using 0.03 millimeter solder here. So it's less than 1/3 of a millimeter, a little bit less. I believe that is good. And now we have to mount the, so I put, oh, the diode. Let's do the diode. I kind of took a little Sharpie, but it's so the cathode goes on this side here. Yep. This diode serves no other purpose than to absorb voltage spikes when the relay is turned off. So it's normally reverse bias, so it's not actually doing a terribly difficult job. Okay, I think that should be making a contact. We will go and check that out with a multimeter. You know, for good measure, maybe we'll put a blob of solder on there. That little solder jumper here. Like that. It was connected, but it's now obvious that it's positive logic. Okay, now this guy here, this is the opto-isolator. We will just do one pin first to make sure that so you'll see that there's a little mark over here. Let's push it up. So that is pin 1. Pin 1, I'll put a little black dot there to remind me what pin 1 was, because you know I goofed up and didn't check that the screen printing was going to be only on the silk screen, and I did not check that, so some of the screen printing is missing, because it's my fault. I'll know next time, so therefore I had to mark it with a pen. No big deal. Right, let's do a pin on the other side diagonally, so it's not going to fall off. Might as well do the pin 1 next to it. Okay. So I think that's all our surface mount components now. Okay, so I've got the relay mounted. So now we have to solder on these pins. I'm going to use some thicker solder for that. I can use this thick solder, and I can actually use my bigger soldering iron. Okay. Now for this I'm going to use a little bit of a different flux. Cheaper stuff. Okay. This is the fake stuff that everyone sells, but it works up to a point, but it's not the real stuff like this. This particular one is andthe 559, and in actual fact this one says 559 ASM UV, but it's not UV. This one shows up in UV. And it has sturry on there sometimes too. I'm using my bigger soldering iron here. This is 110 watts, because these pins, you know, they can handle up to 30 amps. They are thick. Of course, I would never use this this thing up to 30 amps, on account that the household voltage here, 120 volts in the US that I'm currently living in, can only handle up to 15 amps at best anyway, so that gives you a good margin of error if the relay can handle up to 30 amps, then in fact I think it's even more, isn't it? Let me see now. It's 30 amps at 240 volts. 30 amps, that's 250 volts. 1 horsepower at 120 volts. With, 1.5 horsepower is 240. Anyway, doesn't. If it can handle 30 amps at 240, you would think it can handle that 120 as well. Okay. Now, we can solder on this guy here. Strictly speaking, I'm not even sure if I really need to put flux on there. If you've got good solder, it's got rosin core flux in it anyway. But what it actually does is it makes the solder joints nice and smooth and shiny, and not so much in this case a problem, but if you've got some very fine pins on an IC, it stops them from bridging. Kind of, you know, gives surface tension to the solder. Okay, now these got very long pins on them. I'm going to leave them on there for now because they'll allow me to hook up my probes, which will be handy for testing. Okay. Last one, I think that's all there is to it. Now this is going to be my test board. If and when I'm using these things in a project, I will likely not have these little screw connectors on there, and I would solder wires directly to this board. But for testing, it's nice to be able to connect things via little screw terminals. Alright. Now, I'm just gonna clean the flux off there, and then we should be able to do a little bit of testing. Okay, so it wasn't working, and a closer investigation, which I did off camera, I found that the pinout of this transistor over here is wrong. I didn't take any notice. I perhaps should have double checked, I'm not sure. But if you look at what happened, I'm not sure if I really could have picked it up. The problem lies with KiCad, by the looks of it. In any case, I could have worked it out maybe, because I selected this transistor over here, and that is the right transistor, S8050. But if I now go to look at its properties, I see there's a data sheet there, and I didn't take any notice of that. And it didn't have a footprint, so I connected the right footprint there, SOT23. But the problem is that this datasheet is actually, when you look at it, is actually not for a that kind of package. See, it's for a through hole, and the pinout of that one is different. So it has actually caused the pinout to be wrong on the transistor. So again, my bad. The NextPCB people, they don't know anything about that. They just they use the Gerber files that I selected. So I had a bit of a look there, and I found a transistor. It's actually a BC 180 or something that does have the right pinout. You see, pin 2 is supposed to be an emitter, pin 3 is supposed to be the collector, and the base is supposed to be pin 1. And if you select this one, it already has the right pinout. See, SOT23 footprint, and datasheet link. I wonder if I can look at that. Yeah, you see, it is the right package and it has the right pinout. Now it's a different transistor, like the S8050 there. There's supposed to be 60 volts, or collected to base voltage, like its base is actually 6 volts, but it's got the same current and the package is right. So in fact this transistor would have done just fine. So for future use, I'm gonna have some more of these PCBs made, I guess, and I will change that one as well. I can actually go like this and say copy, paste. So I have to take this little transistor off, and somehow I have to let's have a look for a piece of paper here. I have to make sure that pin 1 is going to go to the base, pin 2 goes to the emitter, and pin 3 goes to the collector. So I'll have to have a look what I can do there. I'll do that off camera. Okay, so I was able to salvage the situation by actually taking the little transistor here and just flipping it upside down, and the little legs on those SO23 packages, if you're very careful, you can bend them in the opposite direction. So I was able to solder it in, and so now it is working. If I connect, as you can see, the little LED comes on. That means that there's power there, and you can hear it clicking. Probably hear it. Anyway, so far a successful project, but I think what I'm going to do is there might be some ordinary transistors that actually have the opposite pinout that I could just buy and use on these existing boards, or I could order some different boards from NextPCB. Yeah, so they little boards, they are really nice. Other than, as I showed you, make sure you use that tool on their website in order to upload your Gerber files and have a very close look at them, because then I would have seen that some of the screen printing was missing, but it's no big deal. it's not as though, you know, I really needed that anyway. But the PCBs came into this box, you know, nicely packaged. So I'm quite impressed with their service. It was good and fairly quick. So I'm sure to use them again. So anyway, that's all I've got right now, and I will see you guys later. Don't forget to like and subscribe and all that kind of stuff, and till next time.